The derivation of the formula in getting the correlation, written by Carlo and yours truly. So, first and foremost, the correlation formula that we are going to use is the Pearson product moment correlation. Okay, let's start. The Pearson product moment formula originated from the two formulas. The formula of covariance, which is the opposite of correlation, which is the difference between two variables, and also the formula for standard deviation. Why do we have two? Because we are dealing with two variables here. Let's get right into deriving the formula of correlation as denoted by R. So, in deriving the formula for correlation, we first need to combine these two formulas into a fraction form. So we need to put the covariance formula in the numerator and both the standard deviation would be in the denominator. So it would look like this. Next step is to cancel out n. So how do we do that? So we first need to separate n in this term. So we separate n here, we get that out, so we would put 1 over n here. So 1 over n times the summation of x minus x bar times y minus y bar. Next, we go to the denominator. Since both n are squared, we can multiply these both n to get 1 over n. So square root of 1 over n times square root of 1 over n is 1 over n. You can now cancel both of them. And it would look like this. The next step in getting the formula for the correlation is to divide them into two parts. So we first need to rewrite the numerator and then we would rewrite the denominator. So let's get right into it. First, the numerator. Summation of x minus x bar times y minus y bar. We first need to distribute x minus x bar and y minus y bar. So we would distribute y to x minus x bar and also negative y bar to x minus x bar. So it would look like this. Summation of x minus x bar times y minus summation of x minus x bar times y bar. Next thing is to distribute our y. So we would distribute y in x and we would also distribute y in x bar. In the second term, we don't need to distribute y bar at all because y bar is a constant. So we would just put y bar at the first. So it would look like this. The summation of x y minus summation of x bar y minus y bar times summation of x minus x bar. Did you notice anything familiar? Yes, it's down right here. Summation of x minus x bar. Now, what is it? Now, this specific term is one of a property of the arithmetic mean. Now, this is the sum of the deviation of the actual mean. Now, what would that mean? So, this term right here would equate to 0. So, we need to remember our arithmetic mean so that we can derive the correlation, the formula for correlation. Now, if we have 0 here, we can now divide y bar and 0 to get 0. So, this term right here would be redundant. After getting rid of this term right here, we can now proceed to these two terms right here. So you can actually put x bar outside of this term. So let's proceed to these two terms right here. So the summation of xy is still the summation of xy. Next is this term right here. So we can actually put x bar on the left of our summation. So we can put this outside of our summation. So we would have x, so x bars, then summation of y, right? Now we can also rewrite the summation of y into something. So we would have here summation of y. What could that be? So as you remember, the formula for the y bar or the mean is the summation of y over n. Now, using the summation of y, we could rewrite this term right here. So this term would be x bar times n, because we divide n right here to get the mean, times the y bar to get exactly the summation of y. So this would end up looking like this. So that's it for the numerator. The next part would be the denominator, which is the quantity square root of summation x minus x bar squared times the quantity square root of summation y minus y bar squared. Now, we first need to combine these two terms. So we would have the square root of summation x minus x bar squared times the summation of y minus y bar squared. So let's start first with the summation of x minus x bar squared. So first thing we need to do is to expound this term right here. So we would have like this. Next thing we need to do is to distribute x and also x bar to the summation of x minus x bar. Distribute. And it would now look like this. Now, we then need to distribute our x to the summation of x minus x bar. So it would now look like this. So a summation of x squared minus summation of x bar times x. You notice again that this uh, this set of terms have have one of the property of arithmetic mean, which is this term right here. And now we know that this term right here equates to 0, and if we multiply it to x bar, it would be equal to 0. So we are left with x summation of x squared minus summation of x bar times x. Now we are going to rewrite this term right here. So we would copy summation of x squared minus. So how do we rewrite this? So we can put x bar outside since it is constant. And then we are now dealing with summation of x. Now, the formula for the mean of x is summation of x over n. So we could make an equation that will be used. So we would have x bar times n. So in this case, we would have n times x bar squared, and that's it. So the same thing goes to standard deviation of our y here. So we first need to expound this term right here, which is y minus y bar squared. So expounding it would result into this set of terms. Now we need to distribute our y's and also our y bar to y minus y bar. So it would look like this. So same thing goes to the y's here. We would distribute y, so we would get y summation of y squared minus summation of y bar times y. Now, same thing goes for y. This term right here is equal to 0, and that if we multiply this to y bar, we would get 0. So, so it would result to this term right here. Now, same thing goes for y also. We need to rewrite summation of y. Now, using the formula of the mean of y, which is the summation of y over n, we could write it a equation that equates to summation of y. So we would have n times y bar. So in rewriting this, you would have summation of y squared minus n. So since we have y here, we put this outside. So we have n times y bar squared. And that's it for the y also. So after rewriting the numerator and the denominator, so these three right here, we would put them back together. So it would look like this. So the next step would be rewriting our x bar and our y bar, or the mean of x and the mean of y. So in rewriting this x bar and y bar, we need to get the formula in getting these two. So we already know the formula, which is the summation of x over n and the summation of y over n. So then we would now substitute these two equations to the x bar and the y bar. So it would now look like this. So we're almost there. We need to substitute our n first. So we substitute n here, n here, and our n here. Now it will now look like this. The next thing we need to do is to multiply the numerator and the denominator by n. So it would still be the same if we would multiply both of them by n. So it would now look like this. Seems familiar, right? This would now be our formula of the correlation, the Pearson product moment correlation formula. So thank you for watching this guide right here. See you soon. Bye bye.